Continuing on, we have another test that will give us maximum and minimum values, and that is the second derivative test. This is more information for your cold quiz. And so we have a function such that the second derivative of that function exists on some open interval. So this is some open interval containing some value c, some x-coordinate c. If f prime of c, so that's c is an x-coordinate, is equal to 0, so that means that the function has a horizontal tangent line. And the second derivative is greater than 0. So think about if the second derivative is positive, think to your fun chart, that means that it's concave up. Then this coordinate point c, f of c, is a minimum of f. And the way that we're looking at it, think about, we have that horizontal tangent line right there. The second derivative is equal to, or greater than 0, excuse me. The first derivative is exactly equal to 0. The second derivative is positive. That means that that's kind of like the shape that it looks like, right? So that has to be that relative minimum. And if f prime of c is equal to 0, again, another horizontal tangent line. And the second derivative is negative, which means it's concave down. So you have that horizontal tangent line, it's concave down. Then c, f of c is a maximum of f, and that makes sense from our drawing. Now here's something that is pretty important. If the first derivative is equal to 0 and the second derivative is equal to 0, then the second derivative test fails and you have to do the first derivative test. So these things all kind of go together. And so in a nutshell, that's our second derivative test. And so we're testing to see if we have a relative maximum or a relative minimum. And we don't necessarily call it those. We just call it relative, not relative. We call it maximums or minimums. And so we're just kind of working our way through. We're going to do an example 1. I'm going to work through example 1 using a second derivative test, and then we're going to go through and do a bunch more of these notes. So we've got this function, and we're going to use the second derivative test to find whether f has a local maximum or a local minimum at x equals -3. So that's our c value from our definition, right? We're trying to figure out what's going on. So the first thing that we have to do if we're going to use the second derivative test is we have to take a first derivative. So f prime of x is equal to, let's kind of just do this pretty quickly, 2x squared plus x minus 15. And what we're doing here with this c value, now look back at our definition, like we're evaluating that first derivative at whatever that x coordinate is. And so in this case, we're evaluating it at x equals -3. So f prime of -3 is 2 times 3 squared plus 3 minus 15. And so this is 0. So the first derivative is equal to 0. That maintains like the first part of our definition or our test. So now we need to take the second derivative. So the second derivative, f double prime of x is equal to 4x minus 1. And we're evaluating this. We're evaluating f double prime at that same c coordinate, that same x value, which is -3. So we get 4 times -3 minus 1. And so, wait a minute, that's plus 1, excuse me, plus 1. And so that's going to give us -11. And so -11 is a negative number, obviously. So think back to our tests up here. Since the second derivative is negative and the first derivative is 0 at this coordinate point, x equals -3 must be a local maximum. So let's write out some definition. So we'll say by some justification. Derivative test. X equals 3 must be a local max. And that's your justification.